Hello and welcome back. This will just be a quick video on using StatCrunch to calculate mean and standard deviation using our formulas. So I've gone to Study Plan, and in Study Plan you can go to Progress and click on say the section that we're working on, 5.1, and I want to look at a problem where, given a probability distribution, we'll compute and use the mean and the standard deviation. So let's practice. So this problem, if I make this a little bit larger, says that there are 8 births from eight sets of parents, and the random variable x will represent the number of girls amongst the 8 children. So when we click on the on this here, we'll see, okay, the number of girls is going to be our random variable. So if there are 0 girls, the probability that there are 0 girls is going to be 0.002, whereas the probability that there are 4 girls is going to be 0.242, which is the highest probability here, which makes sense. You expect about half of them to be girls if the probability of getting a boy and girl are approximately equal. The probability of getting the extremes, 0 and 8, are the lowest, and it gets bigger and bigger toward the middle. So this kind of makes sense. So let's open this up in StatCrunch and make some computations. So here we have StatCrunch open, and it's we've got a column for the number of girls and a column for the probability distribution. One thing that we can do is we can check to make sure that this is in fact a probability distribution. First and foremost, we have numerical values, so that's good. Secondly, all of the probabilities of each one of these events, the specific numbers of girls that could be born, each of these is going to be a positive number between 0 and 1, which is good. We can't have negative probabilities, and we can't have probabilities bigger than 1. The one thing that we need to check is to see that the sum of the probabilities is 1. So we can go to Stat, to Summary Stats, and to Columns. And what we can do is we can go to these probabilities. We can select these probabilities, which are called P of X. And under Statistics, we can find Sum. And if we click Compute, you'll see that the sum of this column is exactly 1, which is good. That means that this is a probability distribution. Next, if we want to calculate the mean of the number of girls born, as in the expected value of the number of girls born, we'll need to do a little bit of computation. One thing that we'll need to do is multiply each data value times the probability that that value occurs, and then we'll need to add it up. So let's do this one step at a time. If I come to Data and I go to Compute, I can give in StatCrunch an expression to compute. So in particular, so let's build this expression. I can take x, which is the number of girls, if I double click, and I can take this times P of x. And when I do this, when I click OK and when I click Compute, it will now add a new column, which is the number of girls times the probability that that happens. So we can see that this first column is going to be 0 times something, which is going to be 0. 1 times 0.033 is 0.033. 2 times 0.116 is 0.232, and this makes sense. So one thing I'm going to do is I can rename this so it's a little bit easier to see. This is going to be x times P of x, just so that I remember exactly what this is. And then the mean, what we will want to do is we will want to sum this to find the mean or the expected value. So if I come to Summary Statistics, Columns, I can now click on my x times P of x, and I can come down to Sum, and when I compute this, I get my sum, which is going to be 0.0 4.012, which makes sense, the expected value to be about half of the births. To calculate the standard deviation, we'll have to do almost the same thing, but instead of calculating x times p of x, we need to calculate x squared times p of x. So let's come back to data, compute an expression, and our expression is now going to be x squared, so we'll use caret 2, and just to make sure that this is working, I'm going to add parentheses around this, just to make sure that I'm only squaring this, and then I will multiply by the probability. So now I have a new column which is going to be x squared, so the number of girls squared, times the probability. And just to make it easier to read, I'll write this as x squared times p of x. Great. And the next thing that we'll want to do is we'll want to sum this expression. So again, we'll come to stat, summary statistics, and then columns. And we'll take this column and we will find its sum, which is great, 18.19. However, 18.19 is not the standard deviation. The standard deviation has a little bit more to the formula. First of all, the variance is going to be the sum of this column, the sum of x squared times p of x, minus the mean squared. So let's write these in here. So if I have 18.19, this is the sum of this column, and if I come back, I have my results from earlier. I have my mean was 4.012. Oops. 4.012. And what I want to calculate is in fact going to be this sum minus this squared. So let's come back to data. Let's compute an expression. And here, I'm just going to type these numbers in, which I have now covered up. But it was 18.19 minus 4.012 squared. And we will compute this. And we have this long number, 2.09, and so on and so forth, is the variance. And then the final thing is that the standard deviation is the square root of the variance. So we will need to come back to compute an expression, and we will build the expression that we want. And what we want is going to be the square root, which if we come over to functions and we come down to square root, if I can find this, square root is often abbreviated SQRT, and we will type in our number or as many decimal places as we need. I'll just do a bunch. It doesn't have to be this accurate. And we'll go OK, and we'll compute. And now we have our standard deviation is 1.44. This is quite a lot of work, but it should be somewhat straightforward if you know what the formulas are. We can compute x times p of x if we're given these columns, x squared times p of x. Their sums are going to be the mean, and this sum minus the mean squared will be the variance, and its square root is going to be this. Now, some of these numbers, for instance, something minus something squared, you can easily just type this into Google, and that will do that for you. Also, typing this into Google will calculate this for you as well. If you type SQRT and in parentheses put the number you want, Google can calculate square roots. If this is maybe frustrating to use, which maybe I find, you can either use a calculator or realistically you can type these expressions into Google as well.